Hello, in this video I'm going to talk about using the inverse trigonometric functions to solve for the angles of resultant vectors and solve for the just angles of right triangles in general. So let's take a look at an example related to projectile motion. Here we have a projectile that hits the ground with a horizontal velocity of 20 meters per second and a vertical velocity of negative 50 meters per second. What is the resultant velocity, magnitude, and direction? So let's take a look at this. We know that it has a horizontal velocity of 20 meters per second, so I'm going to sketch out that vector. Vx equals 20 meters per second. And the vertical velocity is negative 50 meters per second, so it's going to have a vertical velocity of 50 meters per second down. It's going to be Vy equals 50 meters per second. And I need to find the resultant velocity, so I need to add these two vectors. I'm just going to slide over Vy to the right, so it's tail to tip with Vx. So this is also Vy, and it's 50 meters per second. And the resultant, or total velocity, is going to be the vector that goes from the tail of the first to the tip of the last. That's going to be V. Now we need to find the magnitude and direction of this resultant vector. The magnitude's easy enough. We can use the Pythagorean theorem. 20 squared plus 50 squared equals V squared. 20 squared plus 50 squared equals V squared. So V is just equal to the square root. V equals the square root of 20 squared plus 50 squared. I plug that into a calculator. I get V is 53.8. And the units are meters per second. 54 meters per second to sig fix. 54 meters per second. However, that only gives me the magnitude of my resultant vector. I also need the direction. So I need to pick an angle, and I need to find this angle here. And this is the angle between the horizontal direction and my resultant vector. Now, we don't have any way of finding that angle right now. There are actually the trig functions which relate two sides to an angle. So for example, I could write out tangent of theta is opposite over adjacent. So tangent of theta would be Vy, which is 50 meters per second, over Vx, which is 20 meters per second. And I can't get this angle theta easily out of there. There's no easy way to take that input out of the function. So I'm actually going to need a new function which reverses the inputs and the outputs in order to get my angle as an output. So let's take a look at our trig functions. I'm going to scroll up. Remember, our trig functions take an angle as an input and spit out the ratio of sides as an output. We have sine of theta is opposite over hypotenuse, cos of theta is adjacent over hypotenuse, and tan of theta is opposite over adjacent. For any type of function, if we want to reverse the input and output, that's what an inverse function does. Reverses the input and the output. And it turns out there are inverse functions for sine, cosine, and tangent. And we just call them the inverse functions, or we call them the arc functions. And they're written in two different ways. Sometimes they're written as arc. Sometimes they're written as inverse. But let's just write them down. If sine of theta is opposite over adjacent, then inverse sine of theta, which is written as sine minus 1, that's not an exponent, that just means inverse. Inverse sine of opposite over adjacent is equal to our angle theta. Similarly, inverse cosine of adjacent over hypotenuse equals theta. I may have misspoke with sine. Inverse sine of opposite over hypotenuse is theta, not opposite over adjacent. And with tan, inverse tangent of opposite over adjacent is equal to theta, tan minus 1. Sometimes these are also written as arcsine, arctan, and arccos. And that's just another notation. It's so we don't confuse that minus 1 sign with an exponent, because it's not an exponent. Arctan of opposite over adjacent equals theta. So these are our trig functions. Notice we can still use SOHCAHTOA to do this. The inverse sine of opposite over hypotenuse is just theta. So if we want an angle as an output, we just use an inverse trig function. So let's apply this knowledge to what we have down here. So if we want to solve for theta, because tangent of theta is 50 over 20, if we want to get theta as an output, we're going to use inverse tangent, or arctan, of 50 over 20, meters per second cancels, to give us theta. And so we just plug in that inverse tangent of 50 over 20 in a calculator, and we get our angle. If I want my angle in degrees, I need to be in degree mode. I plugged it in, I got 68 degrees. So theta equals 68 degrees. And that's it. We have the direction of our vector, and we have the magnitude. Last thing I'm going to do is just write it out clearly. V equals 54 meters per second, and it's at an angle of 68 degrees below the below the horizontal. Because our vector, if we start at the horizontal and we rotate down 68 degrees, we get our vector. That's that. Hope that was helpful. Hope you can use the inverse trig functions now. Bye.